Hi guys, so continuing with the formatting of strings. Okay, so this will be the last part that covers the integer and float formatting. Okay, so what happens here? So let us print this. The number is, and in the parentheses, I am giving colon and D. D stands for integer, basically. Okay, like in C, you used to have percentage %D for printing integer values, and when I say the format as 123, I will print the integer value of it. Okay, a better example would be, let me just copy this and let me keep this 123.456, and then we will check the output. Similarly, for floating numbers, the format is F for float, right? Same as C. Then if you want to converge numbers, right? So we have octal, binary, and hexadecimal format. So there is a fixed format for it. So you have the parenthesis, and in each of the format, 0 : is common. You can see 0 : 0 : If you want to convert the number, let's say here it is 12, to binary, it is B. To octal, this is small o, right? This is case sensitive, it is small o. And to hex, it is the X, right? Because the third character of hex is X, so they kept it as X. Right, so first we will see the output for this. So the output for this will be 123. Again, the output should be 123. For float, it will be 123 and some decimals. Let us just check the output. Oh, sorry, this is not allowed. It won't do type conversion. Type conversion we will see later. Okay. So in this code, the number is D, the format 123. So this is treated as an integer value. The float number is :F. The float number is this. Now you will see here 456790, but actual number is 4567898. Now this is known as the precision format that Python supports. So by default, Python only supports up to 6 decimal digits. Okay, 6 decimal digits. So how many are here? 1, 2, 3, 4, 5, 6. There were 7 here. So what did Python do? It truncated into 6 characters. So 45678 and 98 it made as a 0. So it became 790, right? So 789 became 790. So this is the thing. You can increase the precision. We will see in the later part of the video how can you increase the precision. Then you have octal, binary, and hexadecimal formats. So as I said, for number 12, the binary equivalent, octal equivalent, and hexadecimal equivalent. Here you go. The binary is 1100, octal is 14, and hexadecimal is character C. So you can just see bin, hex, and octal table. Let me search an image just to get a verification. So you can see here for 12, the binary is 1100, which is same as this 1100. For octal, it is 14. Okay, for octal, it is 14, and hexadecimal, it is character C. It is character C. Okay, then we have format 12. We are taking the number 12 and we are giving phi D. Okay, here D specified the decimal or integer, sorry, integer. And phi D, now what does it mean? So you can see before 12, okay, just let me try to print this without using phi D. Okay, let me run the code. So you can see this particular format, right? This is, I say, the first print, just to avoid the confusion. So you can see first print and 12. Okay, so the about 12 is the first print. Let me erase this so that you will understand what does this 5 particularly mean. Oh, sorry. So now just check this 12. This 12 is printed to the most leftmost part of the screen, and this particular 12 is printed a bit far away from the left hand side. So let me copy this output and paste it into a new window. Now just carefully observe. Can you see the 3 dots here? 1, 2, 3, and then I'm writing 12. Okay, but here when I select this, there are no dots on the left hand side. When I select here, you can see 3 dots here. So why only 3 dots here? Because when you select 5D, that means I am giving it the width of 5 characters. Simply said, when I write 5D, basically the interpreter will say, okay, this is just for notation purpose, okay? So I am giving 5 spaces, 1, 2, 3, 4, 5 for printing the number 12. Now the number 12 basically can be fixed in the last 2 digits, right? So I can ignore this. So this comes as space, 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 and 1, 2. Okay, so whatever digits you specify here, that is the width. So for example, if I give here 15D, okay, so what will happen? 15 spaces will be reserved, and the last, it will start putting the digit from the last position. So what will happen here? Let me clear the screen and execute it. So now you can see I have 15 spaces for writing the number 12, which are of course more than enough, like 15 bits. So technically, how do you do a road roller on this? So what I'm saying here in the last statement, I am giving 2 spaces for writing this decimal 1, 2, 3, 4, right? Basically 2 bits of space, but basically 1, 2, 3, 4 requires at least 4 bits. So what happens? This overrides it. So you will see there is no, basically it prints same as if I gave like this. So let me just execute the code. Right, both the cases it is same. So this particular width is only useful when the width of this particular section is more than the digits that you want to print. Now you will say, what is the application of this, right? So for example, if I want to say, okay, let us print something useful. So I will say, okay, name. Okay, let us keep something like a phone number. Okay, and make it D. So let us give some good space. Oh, sorry, 20D. 20D, and in that we will write dot format, and let us specify a nice phone number. Okay, 987-654-3210, and let us say we specify Aadhaar number. Again, let us give a space of 20D. Aadhaar number is 16 digit, 1234 9876 1234 9876, and let us have I think we should give some more space here. Let us give a space of 30 so that there is no overlapping at all. And then we say credit card number 7777. Okay. Now let us try to run the code. So you can see for every particular thing, it is giving a space of 30 characters, right? And then it starts printing from the end. So this is useful if you want to get something having a space between what you're writing, like phone number, Aadhaar number, or credit card number, something like this. So this is just for giving width, right? It is usually used for making the documents appear more beautiful and having more kind of alignment. We will see such more examples in the next tutorial. That's it for this video. Thank you.